Good evening, students. Let us solve a question related to your EMF, terminal potential difference, that is TPD, and internal resistance. The question given here: 4 cells of identical EMF E, internal resistance R, are connected in series to a variable resistor. The following graph showing the variation of the combination with the current output. V versus I graph for this question is given. Means 4 cells are connected like this. Suppose you can take here 4 cells, they are in series, identical cells. They are connected like this to external resistances. The graph between the terminal potential difference and I is given here. And you are asked to calculate the following things. What is the EMF of each cell? What is the EMF of each cell? See, here the terminal potential difference is being calculated for the entire 4 cells. They are connected in series. This is the V versus I graph. So let me remind you how this graph is being plotted. To solve this question, you must know the nature of the graph. So from the graph only we will get our value. This graph is based on this equation. V is equal to E minus IR. This is the equation for which the graph is being plotted. So if you modify it, it would be minus R into I plus E. Try to understand this. So if you plot a graph between V and I, the graph will be a straight line whose slope will give you the internal resistance and the y-intercept will give you the EMF. Got the point? V versus I graph is a straight line. If you see this equation, already I have discussed it in your previous classes. Already I have discussed this in your previous classes. Now the thing is, from the graph how we can find. See, this V is what? The terminal potential difference. I is the current flowing through it. R is the internal resistance. E is the EMF. Now the question is, here in this your equation, E refers to, see, I is your means x coordinate variable, Y is the y coordinate variable. So means this graph is basically your V versus I. And this graph is plotted for 4 cells, not for a single cell. 4 identical cell of EMF E in series. And we know the formula. If 4 identical cells, they are connected in series, then their net EMF is 4E, because E plus E plus E plus E, 4E. And their net internal resistance will be 4R, where this E refers to the EMF of each cell, R refers to the resistance, internal resistance of a particular cell. Try to understand it. Now from this graph, you put I is equal to 0. I is equal to 0 is this point. This is the point where current means origin. At origin, your current is 0. When the current is 0, you get V is equal to E. Means at this point, the value of your E is equal to your V. Means 5.6 volt. So your V is in volt. So in this equation, this I can replace by E net and R net as 4 identical cells. Graph is this one. Now I found if you put I is equal to 0 in this equation, E net is equal to V. Means that is your 5.6. So I can write here E net is equal to 4E, which is 5.6 volt. Now you see, when V is equal to 0, means in this axis, this is the point where V is equal to 0. And this is the point where I is equal to 0. If you put V is equal to 0, means in that case, V is equal to 0, I will be getting your R net is equal to E net by I. Got? R net is equal to E net by I. So for this point, your I is equal to 2 ampere, because at this is the point where V is equal to 0. So we can calculate the R INT is equal to 4R, which is nothing but this E net by I. E net divided by I. Now we can solve. Let us this one. So 4E is equal to 5.6. So E is equal to 5.6 divided by 4. So which is your 1.4 volt. Means EMF, the first answer is EMF of each cell is 4, means 1.4 volt. First answer is 1.4 volt. And the second one, calculate the internal resistance of each cell. So from this, I can put R int, or which is 4R, which is equal to E net. E net is your 5.6. 5.6 divided by your I. Means this is the point where we took the value of I to be 2 ampere, because when V is equal to 0, in that condition only R net is equal to E net by I. For this condition we need to take the value of I when V is equal to 0. In this case I is equal to how much? From the graph it is 2 ampere. So you take 2. So 4R is equal to 2, means R is equal to 5.6 by 8. So which is 0.7 ohm. So students, this is the most important question. You keep this question in your mind. First, if this kind of questions will come, any graphical questions will come in your exam, try to understand the graph, how this graph is being plotted. So what I have done, I just write this formula. So to relate this graph with the formula, means graph is given, I have to remember this formula so that I can link. So from the graph, linking with this equation, I can find out my variables. Students, let us come to the second question. The question is given, a battery of EMF 3 volt and the internal resistance R is connected in series with a resistor of 55 ohm through an ammeter of resistance 1 ohm. The ammeter reads 50 milliampere. The question given, draw the circuit diagram and find the internal resistance of the cell. Also find the terminal potential difference. So let us draw the diagram first. The diagram is saying there is a battery having some internal resistance. Let's say it is a battery connected here, and this is the internal resistance. And a battery of EMF 3 volt. So the EMF of this battery is 3 volt. Internal resistance is R. Is connected in series with a resistor of 55 ohm. So I have to draw a resistor of 55 ohm. 55 ohm, let's say this is R. Through an ammeter of resistance 1 ohm. You take one ammeter here whose resistance is 1 ohm. This is connected like this. So the first question answer is this one. Draw the circuit diagram. Got? And find the internal resistance. Means this value of R we need to find. See, this is the internal resistance of the cell. Ideally this should be placed here, but for simplicity we are placing this outside. So now from the circuit it is very clear that this is the cell which sends current to the circuit. Means the cell is discharging in this case. Means suppose I is the current sent by the battery to the circuit, to this resistance. So the reading of the ammeter means if I amount of current will flow, the ammeter will read also I amount of current, because it is connected in series with the circuit. Clear? So the current that is passing through this resistance is I. Also the ammeter will read the current I. Through that small r also the I amount of current will flow. Second question is, First one is draw the circuit diagram and find the internal resistance. Ammeter reading. Ammeter reads means 50 milliampere. So from the data, let us write down the data what is provided to us. So that EMF, E is given by 3 volt. Small r, we need to find it out. Capital R is your 55 ohm, and resistance for the ammeter RA, it is 1 ohm, and ammeter reading means that is the current in the circuit, which is given 50 milliampere. Now, the simple formula, the current in the given network is given by, your I is given by, we know I is equal to E net divided by R net, means net EMF in the circuit divided by net resistance. Your net EMF as only single cell is there, so your net EMF is your 3 divided by R net, means whatever be the resistance, effective resistance of the circuit. If the effective resistance of the circuit is given by R plus small r plus RA. So this is the effective resistance. You can put the value over here, which is 3 divided by, for R which is 55 plus 1 plus R. And the value of I is given 50 milliampere, which is 50 into 10 to the power minus 3 milliampere, which implies, I can write here, 50 into 10 to the power minus 3 is given by 3 divided by 56 plus R. Now we need to find out the value of R. From this equation, which implies I can write 56 plus R is given by 3 divided by 50 into 10 to the power minus 3, just cross multiplication. This term has come here and this term has come to the denominator. Now let us erase this part. Now if you can solve it, you see here, I can write 56 plus R would be 3 by 10 to the power minus 3, means 3 into 10 to the power 3, means 10 to the power 3 is what? 1000. So which is 3000 by 50. So which is 60. So which implies R is 60 minus 56, that is your 4 ohm. So here the value of R, means internal resistance, is 4 ohm. Got all of it? So the second question is over. Now third question is also find the terminal potential difference. Student, keep in mind, to calculate the terminal potential difference, you see whether the process here, it is a charging process of the cell or the discharging of a cell. Charging, it is a process of your discharging, means the cell whose terminal potential difference is asked, that cell is sending some current to the circuit. Means current is coming from the positive terminal of the battery and it is entering at the negative terminal of the battery. This is the case of your discharging of a cell. Charging means to charge a cell, we need a current opposite to the current flow of your battery. Means it has to deposit the charge. In the case of secondary cell, the current, there will be another source, that source is sending some charge here. Clear? So the direction of the current, whatever done here, that will be just reversed. That I will discuss in a later question. Now you see, in this case, as it is the case of your discharging, in the case of discharging of a cell, as the formula already I have discussed, discharging of a cell, V is given by E minus I into R. Clear? E is your 3 here, I is 50 milliampere, means 50 into 10 to the power minus 3, and your R R is how much? R is your 4 ohm. R is your 4 ohm. Which is equal to 3 minus 5 into 4. So 20 to 200 into 10 to the power minus 3. So 3 minus this will be 0.2. So which is 2.8 volt. Got? So your terminal potential difference VTPD is 2.8 volt. Remember, in the case of discharging, the terminal potential difference is less than your EMF. But during the case of charging, the formula V is given by V is equal to E plus IR. This is the case where terminal potential difference is greater than that of your EMF of the cell, because in this case the cell is being charged by some outside agency. Okay, students. So let us see the third question. The third question is given like this: a storage battery of EMF 8 volt and internal resistance of 0.8 ohm is being charged by a 120 volt DC supply using a series resistor of 15.5 ohm. What is the terminal potential difference, terminal voltage or terminal potential difference of the battery during the charging? Second bit is, what is the purpose of having a series resistor in the charging circuit? Now see students, this is the case of charging a battery. Means a storage battery of EMF 8 volt and internal resistance 0.5 ohm is charged. So this question is different from the previous one, because there it was a case of discharging and it is a case of charging here. So let us draw the circuit diagram for this. So let's say this is your charging cell. It is your 8 volt. Let's say this is the internal resistance, which is 0.5 ohm in this case. It is being charged. Charged means to this terminal some current will definitely come, and at this terminal the current will flow. So let us mark this in this way. Charged by another source whose potential difference is 120. So this is 120 volt battery, means from this battery the current will flow I. And here another high resistance of 15.5 ohm, it is connected like this. Got? So this is the battery which charges this battery, means from this positive terminal I amount of current will flow through this, and the same current will flow through the entire circuit. This resistance is how much? 15.5 ohm. Let's say this is small r, this is capital R, this is your E1 and this is your E2. Now students, we need to calculate, the question it is asked, so what is the terminal potential difference of the battery? Battery means this is a charging battery. Terminal potential difference of across this we need to find out. Means we need to find out the potential difference between these 2 points A and B. So our aim is to calculate the potential difference between A and B, which is your terminal potential difference in this case. Got? So this terminal potential difference, as it is a case of your charging, so the formula is what? It is nothing but E plus I into R. Student, we know the value of E, we know the value of R, but we do not know the value of I in the circuit. So let us write down the data. E is given 8, small r is given 0.5. So if you use this expression, I we need to find out. So to find out the circuit current, I is given by net EMF divided by net resistance. Now what is the net EMF in the circuit? Try to understand it. Since these two cells positive terminal are connected, if you move either in this way or in this way, you see this is the negative terminal of a battery, this is the positive terminal of a battery. And now you see, ideally if they are connected in series, then this will be like this is negative, this is positive, this would be negative, this would be positive. But it is not the similar case. You see, as both the terminals are positive, they are interconnected. So the net EMF is what? This will be E2 minus E1. Why? All of you just see, it is a negative terminal, it is a positive terminal. Negative, positive, again negative, positive means they are in series. Though these two cells are in series, so polarity of one cell is reversed. That case is here. Means this situation you can simplify. You can do this diagram like this. If this would be your E2, this would be your E1. Got? So in this case, though these two are in series, since one's polarity is reversed, so the net EMF is E2 minus E1. E2 is 120, E1 is your 8 divided by R net. This R net. R net is what? The entire resistance of this network. See, as the current is continuously flowing in the circuit, whatever resistance is coming in its path, all are collectively in series. So the total resistance will be how much? It will be this R plus small r. So which is, now the value of the current is 120 minus E1 is your 8. E2 is 120, E1 is 8 divided by R. R is what? 15.5 and small r is 0.5 plus 0.5, and the value is 120 minus 8, which is 112 divided by 16. So the value of the current is, if you divide 16, 7. So 16, 7. So I is your 7 ampere. Clear? So now take this value of I and put it in this equation. Got all of you? Now you put the value of I there. So from this equation, your V is given by E is 8 plus I is your 7 into R is your 0.5. Now, so which is 8 plus 3.5. So your answer is 11.5 volt. So VAB, which is the terminal potential difference across A and B, because this cell is 11.5 volt. But what is the EMF here? Here the EMF is 8 volt, but the terminal potential difference is 8.5 volt. As it is a case of your charging of a cell, in this case your EMF is less than TPD, VTPD, terminal potential difference. So this is the answer of your this question. Now the second question is, what is the purpose of having a series resistor in the charging circuit? But if the series resistor, this resistor would not have been there, then the value of the current would be very, very high. You can calculate the value of the current omitting this capital R. You can find the value of the current in the circuit, and that heavy current will damage this cell. So this cell will be damaged. So to prevent damage, this circuit, this high resistance is connected in series with this charging cell. Okay, thank you students.